Hey guys, Mr. Wilson here. Today we're going to continue with slope-intercept form. At the end of this video, you should be able to write an equation in slope-intercept form from a graph and a word problem. Recall that slope-intercept form is y equals mx plus b. Okay, where m is the slope and b is our y-intercept. The variables in the equation are x and y. Okay, these values change within the same problem. The other letters m and b are not variables. They are constants. Or I say constants because they don't change. They need to be filled in for each problem. And these values don't change within one problem. They are constant. That's why I call them constants. You can just think of them as numbers that stay the same. Okay. Therefore, in each problem, we need to find the values of m and b, our slope and our y-intercept, and plug them into our equation. Okay. Remember that our process is always to start with the y-intercept, which is in our formula b, and then finish with the slope, which is in our formula m. So, first things first, we need to identify the slope and the y-intercept. In this problem, remember, slope is the number in front of x. In this case, it's 1/3. Our y-intercept is the number that's by itself. Remember to keep the sign with it. So it's -4, our y-intercept is -4. Alright, and so let's plot the y-intercept. In this case, that's -4, so we're going to plot it at 0, -4, 1, 2, 3, 4. Y-intercept there. And then we're going to use the slope to find the other points of the line. So our slope is 1/3. Remember, that's rise over run. The rise is 1. The run is 3. 1, 2, 3. Rise is 1. Run is 1, 2, 3. And then, if you're ever in a pinch, it might be good to remember that you could also go negative, negative. That would make a positive. So we could go down 1 and left 1, 2, 3. Okay, notice, see how that continues the line. Okay, straight line through it all. If I can get there. Alright. And there's a line. Remember, don't take shortcuts in line. Draw the line through the graph, please. Thank you. Alright. And there we go. That's our graph. So, today, so this is all yesterday. That's the review from being able to graph in slope-intercept form. Today, we're going to write the equation from a graph. Okay? In slope-intercept form. Again, still slope-intercept form. We're doing the same thing. So again, we're going to start with the intercept, start with b, finish with the slope, or m. Okay, so we're going to identify the slope and y-intercept from the graph. Okay, and so kind of looking at these two values, or two different places. So our slope, we always say slope and y-intercept, but remember, we're starting with our intercept. Hopefully I've said that enough over the past week that you got that. So our intercept is here. This point is 0, 2. Our intercept is 2. So b equals 2. Okay. I'll write that up here because I actually should write my equation near that line, or right under that line actually now. Okay, and then my slope, I'm going to find slope by finding a point that runs into the line perfectly. Make sure I see one. I think I see one right here. Okay, and so from this point I'm going to see, okay, how far down does it go? It goes 1, 2, 3, 4, 5, 6. So it went down 6, and to the right, 1, 2, 3, 4, and over 4. So my slope is down 6, negative 6, and to the right 4, positive 4. I can simplify that to give me negative 3 halves. Okay, so maybe I could have gone 3, 1, 2, 3, and over 2. Yeah, I could have done that. Okay. All right. And so now I have my slope as negative 3 halves. And so the equation of my line is y equals my slope of negative 3 halves, and x always goes after my slope, plus my b, which I just found to be 2. Okay, so start with b, finish with the slope, identify the slope and y-intercept, graph, insert those values in the correct spots in the formula or equation. Sorry for not filling that out. And then write the equation. Okay, and that's where we have it. Backside, going to go through that same process. Okay, identify the slope and the y-intercept. So our y-intercept looks to be 1, 2, 3, 4, 5, 6, negative 6. So b is negative 6. And then our slope, I just need to find a line, there we go, up 2 over 1. So our slope is 2. And so I have, excuse me, y equals mx plus b. I'm going to plug my stuff into the right spot. So I know my b is negative 6. I know my slope is 2. So my equation is y equals 2x minus 6. Okay. Doing the same thing here. Y-intercept, I see it crosses that y-axis at 0. And then my next point that I see is right here, so it goes down 1. And then over 1, 2, 3, 4, 5, 6, and over 6. So down 1 is negative, to the right 6 is positive. And so now my equation I have y equals negative 1/6, because that's my slope, x. And I don't have to say plus 0. Actually, I won't say plus 0. Okay, it'll help me read it later when I'm looking at problems and having to identify it. They don't say plus 0. Okay. I'm going to leave 3 for you to do, so I can make sure that you understand what's happening when I'm coming around. Okay, number 4. Let's look at this one. Now, this is a little bit different for us. Luckily, we've talked about this already. This is a vertical line. Okay, vertical line. Remember that vertical lines equations are a little bit different, right? And so vertical lines equations always starts with x equals, vertexal. Okay, vertical. Starts with x equals, and so we can find out what x equals. 1, 2, 3. Here's our point at 3, 0. What's this point? It's 3, 2. What's this point? It's 3, negative something. I should have picked a closer number. 1, 2, 3, 4, 5. 3, negative 5. Notice that the thing that's consistent in this problem is that all the x values equal 3. Okay. Not necessarily in slope-intercept form, but you should know the equation for vertical lines and horizontal lines. Okay, remember to do 3 on your own for me, please. Thank you. All right, at the bottom here. So we are able to write the equation of a line in slope-intercept form given a graph. Now we're going to try to do the same thing given a situation or a word problem. Okay, and so we have Terrence, who makes $8.75 per hour at his job. Assume he already has $110 saved. Write an equation in slope-intercept form that represents this situation. Okay. What is the slope and what does it mean? Remember, slope tells us how much our points change. So how much does it change for Terrence? Well, $8.75 is what it changes. Changes $8.75 per hour. That's its slope. Remember, slope means change. What's his y-intercept? Remember that y-intercept means start. Where do we start? So where does Terrence start? He starts with $110 saved. And so since we know that slope is 8.75, and y-intercept is 110, we can write the equation of this line. Y equals 8.75 x plus 110. Okay, and this is nice because we can use this equation. Okay, let's say that Terrence works 25 hours. How much would Terrence make if he worked 20, or would he have if he worked 25 hours? Well, we can use our calculator here. I'll move it out of the way just a little bit. Okay, so, oh no, that's too big. Okay, so just getting it out of the way of the equation. All right, so we do 8.75 times 25, because it's 25 hours. Actually, I'll write it out here. So we can just plug it into this equation. Y equals 8.75 times 25, because that's 25 hours, plus the $110 he already has saved. All right, so he works for $218.75, and he adds that to the $110 that he already has, and so that means he has $328.75, and that's the answer to that equation. Okay. So notice that we put 25 in for X because X stood for the amount of hours that he worked. Now let's say that Terrence has $600. How many hours did Terrence work then? Well, same thought process. Y is how much money he has. So let's say, and now they've said that he has $600. We know that. We know that he makes $8.75 an hour, and we don't know how long he's worked, and he started off with $110. And so now we're just solving this equation. I would subtract 110 from both sides, and that gives me 490 equals 8.75x. And now I'll divide 490 by 8.75, and that will give me 56. He is a working man. He works 56 hours. Right. And so you see that this equation isn't just numbers. This equation, even in slope-intercept form, can have meaning like we had in rate of change, and it's useful for us to answer a little bit more specific questions than maybe what we started with. Okay? All right, so now you should be able to write the equation of a line given a graph and given a word problem in slope-intercept form. See ya.